This tutorial from the Project Maths development team is designed to support teachers. Constructing the perpendicular bisector of a line segment using only a compass and a straight edge. All higher level and ordinary level students at both leaving cycle and junior cycle would be expected to perform this construction. Prior knowledge. Students should be able to use a compass to draw an arc, check a right angle with a set square and protractor, use a compass to compare lengths, and understand key terms such as perpendicular, bisector, radius, arc, equidistant, common chord. Let's look at the construction itself. 1. Extend the radius of the compass from one end of the line segment beyond the midpoint and draw an arc. 2. Without changing the radius, draw an arc from the other end of the line segment. 3. Using the straight edge, draw a line through the intersection points of arc 1 and arc 2. This is our perpendicular bisector. Here we have a poster showing the steps involved in this construction. You could pause the video if you'd like to read this poster now, but it is also available as a download in PDF form at the end of the video. Understanding the construction. The perpendicular bisector of a line segment is a line that cuts through the midpoint of the line segment at an angle of 90 degrees. Therefore, it is both perpendicular to the line segment and it bisects the line segment. Any point on the perpendicular bisector of AB is equidistant from both A and B. Hence, the perpendicular bisector of the line segment AB may be understood to be the set of all points that are equidistant from both A and B. Students should also understand that this is how we could construct the midpoint M of the line segment AB. The perpendicular bisector is also the common chord of two equal circles with centres at A and B. This would be another way of performing the construction. So why does our construction work? Our construction involves finding 2 points, C and D, that are equidistant from both A and B, and drawing a line through these 2 points. And this creates a number of congruent triangles. And it is in understanding these congruent triangles that we could understand the construction. Here we have 2 isosceles triangles that are congruent side, side, side. Notice we have some angles that are the same as well. And here we have 2 more isosceles triangles that are also congruent because of side, 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 giving us 4 more angles that are equal. Now if we look at the small triangles, we see we have 4 small congruent triangles because of angle, side, angle. This tells us that the constructed line CD is both perpendicular to AB and bisects AB. In the classroom, giving students the opportunity to practice the construction for themselves is the essential classroom activity. Constructing on grid paper may help students see that the constructed line is perpendicular to and bisects the line segment AB. Students could also be encouraged to investigate congruency. How many congruent triangles can you find? Why are they congruent? This construction also presents a chance to investigate the features of a rhombus. How are rhombi similar to or different than other quadrilaterals? After constructing the perpendicular bisector, students have an opportunity to check the work. How can we check our construction? Using a set square protractor, they could check the lines are perpendicular. Using a compass or ruler, they could check that the line segment AB has been bisected. Which of these methods are more accurate, you could ask students. The perpendicular bisector could also be found or checked by folding paper. A problem-solving task could also be used to introduce this construction. Here we have one based on the Flying Doctors. It is on our website and linked at the end of this video. Dynamic software such as GeoGebra could also be used by students to investigate this construction. Students' understanding of this construction can be developed through suitable questions, such as, can you explain why? What if? Is there another way to? How do you know that? Can you show that? Why is it useful? And students may be encouraged to become fluent in the language of mathematics. This could be done by highlighting key terms or by giving students opportunities to discuss their mathematical reasoning. Looking forward. It is useful to understand that this construction is required for and connected to other constructions. For instance, if you would like to construct perpendicular lines using only a compass and a straight edge, such as a perpendicular line through a point on the line, as done here, we see the construction is very similar. Also, students will be asked to construct a perpendicular line through a point not on the line. Though it's not required that you only do this with a compass and straight edge, it would be interesting to ask students, could they do this having performed the perpendicular bisector construction? This construction has also many implications for senior cycle geometry. Here we see that it's related to the construction of root 3 and required for both the construction of the circumcenter and centroid of a triangle. This construction could also enrich students' understanding of intersecting circles, chords, and tangents. This would be important for senior cycle geometry and coordinate geometry. And finally, teaching and learning resources. Here we have links to some of the many resources available on our website that would help in the teaching and learning of this construction.